Hello everyone, this is Nandini, Assistant Professor from the Department of Information Technology, PSV College of Engineering and Technology. Here I am going to talk about Towers of Hanoi problem, which is an important problem in computer science. Before that, you should understand the concept recursion. Towers of Hanoi is the problem which is solved by using the concept recursion. Recursion is nothing but it is a process which calls itself again and again. It may call directly or indirectly. So there are so many applications in recursion. Few of applications are mentioned here: searching and sorting algorithms, mathematical calculations, compiler design problems, graphics, artificial intelligence problem. So here we are going to discuss about one of the problem in recursion, Towers of Hanoi. So in this problem we are going to solve a puzzle game. There are 3 bits in the problem which have several disks on that. We need to move the disk from the source to destination. So here this is the initial stage. The A is the source peg. We need to move the disk from A to C. Here C is the destination. This is the final stage. So we need to move all the disks. There are n number of disks. Here, for example, we are considering only 3 disks. So we need to move all the 3 disks from A to C. So there are some rules for shifting the disk from peg to peg. So the first rule is only one disk can be moved at a time. The second one is each move consists of taking the upper disk from one of the stacks and placing it on the top of another stack or an empty peg. The third one is no disk may be placed on the top of the smaller disk. So these are the 3 rules. By following these 3 rules, we need to move the disk from source to destination. The step 1. Initially all the disks are placed in the peg A. So the source is peg A. The destination is peg C. So for transfer purpose, we are using the helper, the peg B. So in step 2, we are calling the recursive function. So there are n disks in peg A. We need to move the disk from peg A to peg C. In recursive call, we are considering C as the helper and B as the destination. So we need to move the disk from A to B. So for this purpose, we are using C as the helper peg. So in this stage, we are moving the n-1 disk from A to B. Then we will move to B to C. In step 3, we are moving the next disk from A to B. Now there is only one disk in peg A. In step 4, we are moving the smaller disk from C to B. Now the destination peg is free. Now we can move the disk from A to C directly. So in step 5, we are moving the disk from peg A to peg C directly because there is only one disk. Now the remaining disks are placed in peg B. We need to move all the remaining disks n-1 disk from B to C. So in this case, we need to consider A as the helper and B as the source and C as the destination. So by considering this, we need to move the disk 1 from B to A because A is the helper. Then we move the disk from B to C. Now 2 disks are placed at the correct position. Only one remaining disk is placed in the helper disk A. Now we are moving the disk from A to C. Now all the disks are placed in C. This is the final stage. So this is the transferring method which is used in Towers of Hanoi problem. So there is a pseudocode for Towers of Hanoi problem. We are calling the function Towers of Hanoi with the 4 arguments. First one is disk, second one is source, third one is destination and the last one is helper peg. If there is only one disk in the peg, then we can directly move the disk from source to destination, no other condition. Otherwise, we need to call the function towers of Hanoi. So, we need to move the n-1 disks from source to helper first. So for that purpose, we are calling the function with the arguments disk-1, source, helper and destination. Next, we are moving the final disk from source to destination. Then we need to move the n-1 disk from helper to destination. That is the last step. So after completing this function, all the disks are moved from source to destination. So this is the concept used in towers of Hanoi problem. Thank you.